Hello dear students, I hope you're doing great. Let us start solving structure question on the topic momentum. So question number 1, figure 1.1 shows the speed time graph for a car traveling on a straight horizontal road. So what you have to do, describe the motion of the car shown in figure 1.1. So if you check the motion for the first second, the graph is horizontal. So that means the car was moving with constant speed for first 10 seconds. Then it was decelerating non-uniformly for the rest 40 seconds because you can see the curve. At time t equal to 0, the engine of the car is switched off and the brakes are not also applied. Name two forces that act on the car to cause the change in motion after t equal to 10 seconds. So number one is definitely the forces are resistive forces because the motion of the car is actually decreasing, that means it's decelerating. So one is friction with road, it actually reduces because speed decreases. Then the air resistance also changes, so they are asked to mention the name. Says why the figure 1.1 the curve is a curve after 10 seconds because resistive forces change as the speed decreases, so the resistive force also decreases. Now between 10 seconds and 20 seconds, the speed of the car changes from 18 meters per second to 11 meters per second. The mass of the car is given 1200 kg. So calculate the change in momentum of the car in this time, give your unit. The change in momentum means final momentum minus initial momentum. So m equal to v minus u. That means 1200 multiplied by 18 minus 11, which is equal to 8400. That means 8400, and it's in kg meter per second. Calculate the force, average resultant force exerted on the car during this time. So we know that force is rate of change in momentum, that means change in momentum by time. So change in momentum is 8400 and the time is 10 seconds, that means is 840 Newton. 840 Newton. So let us move to question number 2. A spacecraft of mass 300 kg is moving in a straight line in a space at a speed of 8000 meters per second. Calculate the momentum of the spacecraft. Momentum equal to mass multiplied by velocity. So which is 300 multiplied by 8000. It means 24,000,000,000. So we can write in the standard form. 10 to the power 6, 2.4 into 10 to the power 6. Now the fuel on the spacecraft exports and the spacecraft splits into two parts. The direction of the which part moves does not change. That means they are moving in the same direction even after explosion. So after explosion, the speed of the front part increases to 9000 meters per second and the mass is 150 kg. And the calculated speed of the rear part after the explosion. So in this case, we have to use the conservation law of momentum. That means momentum before explosion and after explosion will be same. The mass changes, velocity changes for the both part. So we already found it. That is 24,000,000,000 equal to First one is mass is 1 and it's 9,000. Since the first part is 150 and the total mass is 300, the rear part will be also 150, and we don't know the speed. So that is v2 equal to 240000 minus 150 into 9,000 divided by 150, and it will be 7,000. That means 7,000. Okay. Now B2. The total kinetic energy of the two parts after the explosion is greater than the original kinetic energy of the spacecraft. State the energy transfer that occurs in the explosion. It was carrying fuel, and fuel is the source of chemical energy. So energy was transferred from chemical stored energy. Stored energy. Okay. See, the explosion lasts for 0.20 seconds. Calculate the average force on the front part. So we know this change in momentum divided by time is the force. So the change in momentum. Initially, its mass is 150 and its speed was initially 8,000, and later it changes to 9,000. That means 9,000 minus 8,000 divided by time, 0.20 second. We can use the calculator. Multiplied by 9,000 minus 8,000 divided by 0.20. That means it's 750,000 Newton. 750,000 Newton, which can be written as a standard form 7.5 into 1, 2, 3, 4, 5, 10 to the power 5 Newton. Okay, so let us move to the next question. Figure 3.1 shows two trolleys. On the front end is front of the trolley A. There is a wooden rod. This is the wooden rod, and the trolley B is initially at rest. As the trolley A moves towards the right, the rod enters the modeling clay, and the trolley A slows down and trolley B starts moving. The trolleys then stick together and continue moving towards the right. Okay. Figure 3.2 shows the speed time graph for the two trolleys. The trolleys start to collide at t equal to 0.30 second. At 0.50 second, the trolleys are moving at the same speed. Instead, how the figure 3.2 shows that during the collision, the trolley B has a uniform acceleration. Which one is trolley B? This is trolley B. So you can say the speed time graph is there is an inclined straight line. So definitely the slope is constant, and from the speed time graph we can get the acceleration. So as the straight line, the graph is a straight line. I should change my pen. Okay, describe how the graph in figure 3.2 shows that the magnitude, that means size of the acceleration of the trolley B, is larger than the magnitude of the deceleration of trolley A, because gradient is bigger, and the gradient of the speed time graph is acceleration or deceleration. So what you can write here? Gradient of line is steeper or bigger? gradient of line B is larger. Okay, so move to the next question. Calculate the acceleration of the trolley B when t equal to 0.40 second. What is t equal to 0.40 second acceleration of B? So at 0.3 second, at 0.3 second it was 0, and at 0.4 second, what is this? This is the 0.2 is 0.2 meter per second. So A equal to change in velocity or slope of the graph, 0.2 minus 0 divided 0.4 minus 0.3. So 0.2 minus 0.1, that means 2.0 meter per second square. Okay, the mass of the trolley is 0.80 kg and the mass of the trolley is 0.60 kg. Show that the momentum is conserved in this collision. Show that the momentum is conserved, that means before collision and after collision the momentum must be same. P equal to initial mv plus 0, that means 0.80 multiplied by what was initial speed, 0.7, 0.56 kg meter per second, and after collision means final momentum, they stick together, m1 plus m2 into v. So one is 0.80, another is 0.60, and their common speed is 0.4, so which is also 0.56 kg meter per second. So momentum is conserved. So if you have doubt, you can check it. Say this is 0.4. Now the final question. In another collision between the same trolley, the rod and the modeling clay are not present. Trolley A hits the trolley B with the same initial speed. Explain why the force between the trolley is larger in this collision. So there can be different reasons. One is contact surface might be very rigid. Contact surface might be rigid. So this is, you are getting 1 mark. You have to write another point. Or it can be time of collision can be less. Time of collision might be shorter since the force was increased. No, there was no rod and model there. Shorter, or acceleration is increased. So this is the answer of question 3.